There's antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, and protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, bromide, lithium, beryllium, and barium. Isn't that interesting?
3, 2,
I hope you're all paying attention. There's going to be a
fire.
short quiz later on.
Okay.
There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium and manganese and mercury and molybdenum and magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium and platinum, plutonium, palladium, promethium, potassium, polonium and tantalum, technetium, titanium, tellurium and cadmium and calcium and chromium and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, krypton, neon, radenzine, and zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard. And there may be many others, but they haven't been discovered.
Hi, I'm Chemical Charlie.
Hi, I'm Pie Guy Pepin.
And what do we have here, Pie Guy?
This is a wood block, and this is a metal block.
And they've both been sitting in this room for several days, so they should be at the same temperature. But
we are about
feel this one, yeah.
temperature.
We're warmer.
So it feels colder to touch this one, but it doesn't seem to feel as cold to touch this one.
Okay, so the metal one seems to be colder, feels colder to the touch. Now, why is that?
It's because metal is a better conductor of heat.
Okay. Now, suppose we put something cold on these, or suppose that we made them hotter than our body. Which one do you think would feel warmer?
The metal.
Because it would be transferring heat faster to us than the wood. The wood doesn't transfer heat. It's not a good conductor of heat, either from it or to it. Okay, so what should we do next, Pie Guy?
Put an ice cube on both of them.
All right, so let's, first of all, let's put an ice cube on the wooden one, and you can see.
It doesn't really melt much, but when you put one on
Look at what's happening there.
It does melt a lot.
All right, let's count. 5, 6, 7, 8, 9, 10, 11, 12. In about a minute and a half, I would say it's going to melt completely.
So why is ice a better? Why is metal a better conductor?
Well, it has to do with the atoms and the electrons. I don't think we want to get into that. I don't understand it too well myself, but it is a much better conductor of electricity and heat. And so the heat from the metal gets transferred to the ice cube very quickly, whereas this one is just sitting there. It's just like an insulator. It's melting a little bit, but there's a tremendous difference in these two. And it's a nice illustration of conductivity, but not conductivity of electricity, conductivity of heat. But they often go hand in hand. Okay, this is Chemical Charlie.
And Pie Guy Pepin.
And we'll see you next time.